First sections are about LOL, or energy transfer diagrams. There's some multiple choice that go along with these. They're going to be asking about things like thermal and phase energy. That first one says when a sample of liquid is cooled, it's thermal energy. And what happens? The word I'm going to key on is thermal energy. If we remember, if we have something cooling, maybe it was steam, 110 degrees, it's going to cool off until it gets to 100, flatline while it condenses, cool off till it gets to 0, flatline while it freezes, and cool off some more. So that the two phases, or the two energies we're going to be dealing with, are thermal energy, which will mean a temperature change, and phase energy, where there's no change in temperature. So the first one says, when a sample of liquid is cooled, it's thermal energy. Very obviously, if it's thermal energy, the temperature is cooling, it's going to be decreasing, B. But when a sample of liquid is freezing, that's this point right here, the freezing point, there is no change of energy. So when a sample of liquid is freezing, its thermal energy, C, remains the same. Down here is a heating instead of a cooling. The graph at the right represents the temp time behavior, what was initially ice at 0. And they're going to ask us some questions, and here are our 4 choices. During region B, definitely a slope. The temperature's going up. The thermal energy is A, increasing. But during region C, even though we're adding heat, the thermal energy isn't doing anything. It is the same. Or letter C. During region A, what's going on at A? At 0 degrees, we add heat. It is melting. When something is melting, its phase energy is increasing. So the best answer there would be letter A. During region C of the graph, above, the energy being absorbed is in, what's the energy doing? So it's C. It's not heating it up. What is it doing? Well, it's evaporating it. It's vaporizing it, but that's not one of our choices. Is it increasing the velocity? Increasing the velocity would mean that its temp was increasing. No, I think no. Is it increasing the distance between the water particles and reducing their phase energy? I think as we add heat, it's going to separate them, make them jump out of the pan, but it's going to increase, not reduce. I'm thinking no. Is it increasing the distance between the water particles? I think so. And increasing their phase energy. C is sounding good, but let me check D. Decreasing the velocity. No, that would mean if it was cooling off. C is going to be, I'm going to erase all this and say C is my best choice there. And I'm going to skip over to the LOL. There's only one of them here. We'll probably have more, but so let's walk through this idea. A tray of water is placed in the freezer and it turns into ice. Well, let's see. We're talking about the water or the H2O. I write the system in the middle. That's how I start an LOL. It was liquid water at the beginning, which has 1, 2 phases. Remember that 1 bar is a solid or ice. 2 bars is a liquid or water. And then we skip 3 bars and get all the way to 4 bars if we happen to be in a gas or a steam gas, because it takes a lot of energy to make it fly around. So tray of water starts off with 2 bars of phase. Later on it's going to turn into ice. That's only 1 bar of phase. How warm does it start? I get to just make this up. I'll just say 3 thermal bars. And when we're done, it's pretty darn cold, so I'm going to say 1 thermal. Ultimately, then I have 5 bars being turned into only 2 bars. So it looks to me like 3 bars, 1, 2, 3, exit the system.